Hello, my name is Nathan Fix, and this is my technical project for GIT 335. I will be basically looking at the hardware that goes into computers and what it is that's necessary to make them work. I'll be going through many of the components necessary to actually physically build a computer, and talking about kind of on the more technical side how they all interact with each other and why everything is necessary where it is and exactly what it does in the function of the standard consumer computer. And I will be doing this by essentially hypothetically building a computer, and kind of taking you with me through the process. Alrighty, so starting out, we're basically going to start by looking at the motherboard, which is essentially the backbone of any personal desktop computer or even laptop computer. There's a lot of different options if you're looking to, say, buy a motherboard or essentially just looking to learn more about them. But essentially, the motherboard is just a series of circuits on a board, which is why they call it the motherboard. It's a series of circuits and slot openings where basically everything else that makes the computer is connected. So today I'm going to be looking at a very specific motherboard. I'm going to be looking at the Asus Z170A, which is a relatively new motherboard to the market, and we're going to take a look at a lot of the specifications and kind of explain what they all mean in detail. So taking a look at the specific list of specifications, you can see right off the bat that the manufacturer is Asus. That's just the company that makes it, and the part number is just that, a part number. The form factor, ATX, is essentially just the industry standard for all of the other parts that are going to be connected to the motherboard, and it's essentially just letting you know that, hey, this motherboard is compatible with the industry standard of plugins for parts. The CPU socket, that's essentially just the type and size of the opening in the motherboard where you would plug in your central processing chip, what we call the CPU. Taking a look at like the chipset size, for example, that just lets you know that this is a motherboard that's meant to work with Intel processors that fit within the Z170 metric. Memory slots, essentially that's just letting you know how many memory slots there are, and then as well as the type of memory slots that they support. Memory type is essentially just up to the type of memory sticks, and we'll get a little into this a little bit more when we talk about RAM and short-term memory. But essentially, the memory type is just letting you know what iteration of RAM this motherboard supports, as well as the speed at which that RAM can be supported up to. The maximum supported memory is essentially the maximum amount of RAM that you can have on this motherboard that it would support. Other important stats to look at, especially if you're looking to build a PC or looking at replacing your motherboard, is how many SATA ports there are on the actual motherboard. This is important because essentially most of the external things that you plug into the motherboard, such as hard drives or solid state drives, all use SATA ports. So you want to make sure that you have enough based on the other things that you're going to need to be plugging in. And then the onboard Ethernet essentially just lets you know the speed at which the Ethernet plug on the motherboard will support. So next we're going to be taking a look at the central processing unit, which is the microchip processor or CPU, essentially the brain behind a computer. CPUs really have come a long ways, and there's two main major manufacturers, Intel or AMD. Some people prefer Intel, some people prefer AMD, but at the end of the day, as long as the specs are good, it's all the same. So there are a few key differences between the manufacturers and how they build their CPUs, but it's not that important to take a look at when we're just looking for general knowledge behind the CPU. So I've picked out a CPU here that I'm going to be looking at in conjunction with the other parts that I'll be putting together. And I believe that building a hypothetical build of a PC is a really good way to kind of explain how all the parts work, how they work together, and what exactly they all do when they're working together. So that's essentially what I'm going to be doing this evening. So we've already taken a look at the Asus C170A motherboard, and essentially now we're going to be taking a look at the Intel Core i7-7700K, which is pretty much a brand new processor. It's the newest one that Intel has on the market. And we're basically just going through the spec list and kind of just making notation of everything and making sure that everything's going to work. And I'll explain everything as we read over it. The manufacturer and the part number are fairly self-explanatory. The data width is essentially just the width of the band of data that this type of processor supports. Usually you're either looking at 32. Most processors these days are 64. You'd be hard pressed to find one that wasn't. So it's really not that important. The socket type is very important when you're looking at building an actual PC, and you essentially just want to make sure that this is compatible with your motherboard. And as you can see, the one that we have chosen here is in fact compatible with our motherboard. The operating frequency is essentially call it the clocking rate, is another way to call that. And the clocking rate is essentially the speed at which the processor processes data. Cores it's a bit of a complex idea, but essentially the idea behind cores is that you have all of this data coming into your CPU, and the amount of cores that you have is essentially how many terminals where data is being processed. So for example, a 2-core CPU has 2 places where data can be processed at the same time. The more cores you have, the more spread out the processing can actually be, and typically processing is spread out equally among all of the cores available, which allows the CPU to basically do a lot more multitasking at the same time and work essentially a lot harder without overheating or overpowering itself. The quad core is fairly standard for computers these days. The cache information is not overly important for building PCs. The other real important statistics we're going to want to be looking at here is looking at the thermal design power, and the reason for that being that once we finish basically putting everything into our CPU, we're going going to need to find a power supply that's powerful enough to power the computer that we're building. And then essentially you want to look at the maximum supported memory and make sure that the CPU will be compatible with the amount of RAM that you're going to be installing in your computer as well. And we'll get to that in just a second. So the next computer component that we're going to be taking a look at is the CPU cooler. And now, just as important as the CPU in a computer, the cooler is as well. There's two ways you can go with your CPU cooling. You can either use a traditional cooler, which is a heat sink and a fan, which is the one that we're going to be taking a look at today, or many more high-end PCs look at using what we call liquid cooling, which is essentially just a water cooling system that cools the entire system. But today we're going to be taking a look at the Cooler Master Hyper 212 Evo, which is a traditional CPU cooler. So essentially, looking at the components of a CPU cooler, there's only real two components to it, and that's going to be the heatsink, which essentially attaches directly to the back of the microprocessor chip, the CPU. And essentially what that does is it's made of copper and aluminum. The copper especially is a very heat conductive material. So basically that whisks the heat away from the actual processor itself and into basically the grate, where you attach a fan, and then the fan just blows air through the grate, cooling the whole system off. Looking at the actual specifications, the only real important things to look at with a CPU cooler are the supported sockets and the height. You essentially just want to make sure that the CPU socket that you have chosen for your motherboard is also compatible with your CPU cooler. And I believe the one that we chose for both the motherboard and the CPU is a LGA 1151, which, as you can see, is supported by the cooler that we've gone with today. Like I said, the other important specification to look at is the height of the cooler. And that's important because if it's too tall, it may not fit into a standard computer case. That's the big metal case that the computer is built inside of. You just want to make sure that the height of the CPU cooler is not going to extend beyond the width of the case. So the next component that we'll actually be taking a look at here is the RAM, also called short-term memory or just memory. It's essentially the computer's ability to multitask. The more processes and more applications that a computer is running at once, the more RAM it will need to do so, at least to do so optimally. It's very standard for office computers or personal computers to have either 8 or 16 gigabytes of RAM, because most consumer products and software doesn't use more power than that. It's fairly uncommon to see personal computers with more than 16. Once people start getting into more professional setting, working either in like engineering or even for personal use for things such as gaming or basically just high activity processes that require a lot of power and multitasking, that's when you begin to see up to 32 or even 64 gigabytes of RAM, but it's fairly uncommon. So the RAM that we're going to be taking a look at today is the G-Skill Ripjaw series, which I have essentially selected because it's a run-of-the-mill RAM that would be very affordable for a standard PC build. Essentially, again, the part number and manufacturer are very self-explanatory. The 288 pin, that's essentially the amount of physical pins on the actual RAM, and this is essentially just to make sure that it lines up with the motherboard that you're using. And it does, in fact. Our Asus Z170A is compatible with 288 pin sticks of RAM. The next most important thing is to take a look at the speed of the RAM and make sure that that is compatible with the motherboard that you're using. So if you take a look at the motherboard, you see that the memory type, it says it supports a DDR4 of various different speeds. And then if you take a look at the RAM that we're actually using, the speed is noted at DDR4 2400. And what that essentially means is that DDR4 is the iteration. DDR3 was standard for a very long time for personal computers, but DDR4 is faster and essentially become the industry standard now. DDR1 and 2 are for older, more primitive computers, and DDR5 and 6 do exist, but they're typically used for server and mainframe computers. So DDR4 is typically the industry standard for consumer computers these days. So for the RAM specification list here, you can see that the speed of our RAM is DDR4 2400, which our motherboard does support. The size is also important because it lets you know essentially how much RAM you're getting and in what breakdown. So on your motherboard, you have typically 4 slots for RAM sticks. When you see that the RAM that we'll be looking at today, the G-Skill, is 16 gigabytes total, and that's 2 8-gigabyte sticks. So the next component that we're going to be looking at is actually storage. Storage is really important and very unique on computers because it's kind of confusing when you first are learning about the way the computer components work, because you're considering that memory would typically be the same thing as storage, when in fact mean short-term memory or memory essentially that's processes that are currently running or running in the background that your computer may not be actively processing but are still open and running in the background, versus storage, which is essentially long-term storage where data is actually being stored. And there's 2 different types of standard storage. First being the traditional hard drives, which is essentially just a disk that is constantly being written and overwritten, and SSD, which means solid state drive, which has become a lot more standard within the last couple of years. Just to give you a brief rundown, solid state memory, or what they call flash storage, is very quickly becoming the industry standard, and it's essentially just large thumb drives. The way that flash memory works is basically by taking a series of smaller chips like you would find in like a flash drive or a thumbstick, putting them all onto a controller board, and then rating them all together, which essentially means just tying them all together so that they all function as one large storage. So it's fairly common to see one or the other or both of these storage methods in consumer computers these days. We'll be taking a look at one of each just to kind of cover all of our bases and look at the advantages and disadvantages of each. So starting off, we'll take a look at our hard disk. And the one I've selected here to take a look at is just a Western Digital 1 terabyte 3.5 inch that clocks at around 7,200 RPM. Manufacturer and part number are, again, very self-explanatory here. The capacity you can see is 1 terabyte, which is 1,000 gigabytes. One of the most important differences between the hard disks and solid-state drives is that hard disks still have moving parts, but it is a lot easier to get more storage in them. So you get a lot more storage for your money, but it's typically recovered a lot slower from the actual drive itself. So, for example, the 1 terabyte hard drive that we've taken a look at here clocks typically anywhere from $50 to $65 versus the solid-state drive, which we'll be taking a look at, the Samsung 250 Evo series 250 gigabyte, and that's a 2.5 inch, so it's a slightly physically smaller drive. The data it stores is only a quarter of the size of the hard drive, and you're essentially looking at paying double the price. But there's no moving parts, there's less room for failure, at least on the physical side, and essentially they move a lot faster as well because there's no moving parts. So taking a look back at our Western Digital hard drive, you can see that the capacity is 1 terabyte, which is essentially pretty self-explanatory. The interface is essentially the type of plug that it uses to connect to the motherboard, as well as the speed at which it transfers data. And the RPM is essentially the rate at which the drive reads and writes data from itself. So flopping over to the Samsung 850 Evo solid-state drive, you can see that essentially it uses the same type of SATA interface, so it transfers data at the same rate, but the fact that it is a solid-state drive means that it will be able to boot up and read and write data much more quickly than even like a 7,200 RPM, which is very high. It's on the high end of standard for hard drives. So the next component we're going to be taking a look at is video cards, which are also known as the GPU, and they are typically very optional on computers. The essential purpose for a GPU or a graphics card or a video card or whatever you want to call it is that it basically splits the graphical processing data of what's going to be displayed on the monitor, so that you have essentially two processors in your computer. One that is exclusively for processing visual data that is going to be displayed on the screen, and one that is for processing all other basic data for the computer, and that is your CPU. It's very common to see GPUs in more high-end computers, especially those that will be used for gaming or like rendering, video editing, that kind of thing, because there's a lot of visually potent things that are being displayed on the screen, and a lot of times standard CPUs don't have the onboard capabilities powerful enough to reproduce those for a monitor very well. And you can see if you're taking a look at a CPU that they do have onboard graphics to some degree. All of them are designed to be able to display things to the screen as well as process within the computer itself, but nothing that they have is overly substantial or very powerful. So it's fairly common, but also very optional to pick up a GPU for your computer. So basically I've taken a look at two different GPUs here, one made by NVIDIA and the other one made by AMD. You may recognize the name AMD from when we were talking about CPUs, and that's because, both types of processors are made by an AMD. So starting off with the NVIDIA one, we're going to be taking a look at an NVIDIA GeForce GTX 1050 Ti. You'll see here that the one that I've selected is essentially manufactured by a different company, but it's using NVIDIA's technology. All of the GTX brands are trademarks of NVIDIA that they license out to other companies such as MSI, which is the one that we're using here for manufacturing. So the part number is just the GTX 1050 Ti, and that's a lot of techie sounding lingo, but so you essentially break that down into two separate numbers. The 10, which is the 10 series, which is their newest version, and then the 50, which is essentially the power or strength of the GPU. The 1050 is essentially the most basic version of the newest iteration, if that makes sense. So taking a look at some of the other specs that we have here, it basically gives you the chipset, the GeForce GTX. We already kind of broke that down. The memory size is the amount of onboard VRAM or visual RAM. Processing visual data is different from processing non-visual data. Non-visual data, typically you have your memory stored within your RAM on the computer, versus with GPU and visual data, anything that's being displayed on the screen is going to take up a certain amount of space even while it's being processed, and that is what your virtual RAM is for. The boost clock is essentially just like the speed at which the GPU processes data. Fan, essentially just a yes or no question as to whether or not it even has a fan. And then taking a look at the size is actually just the size of the actual product itself. And then looking at the bottom, you can see the different types of ports that it has available. It has one of each, DVI, DisplayPort, and HDMI, which is essentially where you plug in like an HDMI cable that you would run to your monitor. Taking a look at the other GPU, the MSI Radeon, which is essentially just the AMD Radeon, but they again license their products out to be made by MSI or other companies. The Radeon RX 480, that's the newest iteration once again of processor that's been brought out by the AMD. That's the 4, but 80 is the actual power of the GPU itself. So it's a little bit confusing because there's two different companies and there's no standard for how they measure the power of their graphics units, but it's essentially just worth noting with which company you're actually looking at. As far as the actual statistics, they're all very similar. You still have the same memory size. This one actually offers memory type, which is fairly unimportant because it's just a memory type. We were talking about DDR4 before. This one has DDR5 for that 8 gigabytes of virtual RAM that you'd be. Other than that, it's fairly self-explanatory for the rest of the stats because a lot of them carry over from one to the other. So the next component we'll be taking a look at here is a case, and what that means is just the physical case that you'll be building the actual computer within. There's several different types of cases. It's kind of a whatever floats your boat kind of thing. As long as it's compatible with the type of motherboard that you have, you're really not constrained by any other metric on your case. The one I'm looking at here is going to be the Corsair 300R, and the only reason I chose this case is because I know that it's large, it's very basic, and it is great for explaining the different features that a case can offer. Essentially, the most important statistic to remember on a case is the type, the ATX mid tower you can see right here. And the reason that's important is you just want to make sure that the ATX tower is compatible with an ATX motherboard, which ours is. Color is very self-explanatory, includes power supply. That's also very kind of important because if it does include a power supply, you may not need to buy one for your PC if it's powerful enough, but this one does not come with a power supply. External bays are essentially just the openings on the front in which you could just install things like Blu-ray or DVD drives. Internal bays are essentially where you'll be installing your solid state drive or your hard drive or both. It says right there your motherboard compatibility, ATX, micro ATX, or mini ITX. Lets you know how many USB 3.0 panels on the front of the actual case rather than just on the back, and the maximum video card length that this case would support. Other than that, they're fairly self-explanatory. So the next component that we'll be looking at is going to be the power supply. And of course, this is one of the most important because the power supply is the unit that will be providing power to the motherboard and the rest of the computer. The one that we'll be taking a look at here is an EVGA Supernova 650, and all that means is that it's essentially a power supply that's meant to be plugged into an outlet like into your wall, and that it supports up to a computer build of 650 watts. And essentially what you need to do is if you're taking a look at a computer build, something similar to what I have here, you just want to basically go through all of your parts and add up all the wattage that they will be consuming and make sure that your power supply is equal to or more than that. After doing all the math on our computer build, I've calculated that the one that we're looking at here would only cost us about 287 watts of power, and this EVGA Supernova 650 supplies 650 watts of power, so we're kind of going overboard, but this is a really good power supply for a great example because it has a couple of extra bonus features such as fans, and then it explains the power efficiency as well. So fans is fairly self-explanatory. That's the amount of fans on the power supply unit itself, how it keeps itself cool and keeps itself from overheating, as well as protects itself from surges. Then power efficiency is just how much power is it losing or not losing between the wall and the motherboard, and you can see that the efficiency of this one is 90%, which is fairly standard. So the last piece of hardware that we're going to be taking a look at today is the optical drive, also known as the disk drive, DVD drive, Blu-ray drive, whatever you want to call it. These are becoming less and less common actually for consumer computers. You notice that like the new MacBook Pros don't even come with CD drives anymore. They haven't for a few years, but they're still fairly common on desktop computers because it is sometimes still necessary to actually be able to read and write disks, although it is becoming an obsolete technology, and I wouldn't be surprised to see these completely gone in the next 5 to 10 years from most computers. But when looking at these, the only really important statistics to even look at are just whether it can read as well as write, whether it's capable of managing data from DVDs, CDs, or Blu-rays. If yes on all of those things, then you're absolutely set and you're all good to go. So that basically wraps up all of the hardware necessary for the average computer. I hope that this has been helpful, and I hope that you learned something about computers, the components that are necessary to make them work, and about how the components all interact with each other on a kind of a more technical side. Please feel free to leave me any feedback. I absolutely appreciate constructive criticism. Otherwise, thank you for joining me today.